Hey guys, welcome to the third update. We got a lot to go over, so let's just jump right into it. First off, we got secrets put into E1M2. Then we got more of E1M2 built, so had to make rooms and everything like that, alternate paths. More sprite work done, so those will be able to be used for both this level, previous levels, and future levels. So more sprites are always very nice to have. I did even more work on the elevators, which we'll go over after I do the update here. Elevators might not sound very difficult, but you'll find out soon that they are actually a pretty good description of what it is to code for a game. Got more things modeled out, and like I said, most of the game is going to be sprite based, but there are certain things that you do need to have modeled out. Things like tables and chairs, things that you might need to go over, go around, potentially go under. So it's good to have things modeled out, and things like tables and chairs, you can reuse those across any level. So really nice to have those made. Got ambient sounds put in. I added new ambient sounds, and I also kind of figured out some new tricks with ambient sounds to make them a little bit better, which is nice. But that also means that I'm going to have to go back and change up a lot of the other sounds that I've already made with this new stuff that I've learned. So that means more work, but it also means higher quality sounds. So we'll just call that a plus. It'll be a plus once the work's done. And then next we got ambient sounds in E1M2. Yeah, I got those put in, so hooray for that. The nav mesh put in. Nav mesh is essentially just, it's basically just saying where the AI can walk. So it basically allows the AI to path around in certain areas. And you can, for instance, disable the nav mesh in certain areas where you don't want them to walk. So got that done. The pickups were put in, so keys, ammo, weapons, armor, health, things like that. I added new information onto the Steam page for the game, which is really just a bunch of different sized icons, but it's progress. It is technically on Steam already, but you just can't find it. It's hidden until I get a certain amount of things done, one of which, the main one really, being a playable build of the game. So I'm going to wait until I have the first episode done before I get that sent in, but things are being done on Steam on the back end at least. I also began setting up the Discord server for the game. That's not low priority, but it's not exactly something that I'm going to work too much on at the moment. Something where, you spend like an afternoon and it's done, but I don't really have much of a reason right now to start building it up. So we'll get to that soon, but not right now. Adjusted enemy vision and hearing distance. This is kind of a big one because it goes into enemy balance. Before the enemy, I didn't really have it visualized just how far I had their vision and hearing set before, and so they could see and hear you from basically across the entire map. And in this map, so E1M1 is a lot longer than E1M2 was, and by longer I don't mean in terms of how long it takes you to get through the map. I just mean in terms of distance. And I noticed that the enemy could actually see you across the entire map there. In E1M2, where it's a lot smaller, or more compact, really, they were able to hear you and see you from literally anywhere in the map. So I had to alter that quite a bit. So that's a big one for enemy balance, and enemy balance is something that I'm going to need to really kind of like sit down and grind out a little bit, because right now they're tough. They're really tough. But I need to try to add a little bit more nuance into them and kind of figure things out with what I want to do with them. So I think probably before I get into E1M3, we're going to be kind of slowing down and really taking a look at the enemy. And a lot of the enemy balance is going to come into play when I start getting it, testers to actually play the game and be able to play it as, a new player and be able to get other people's experience. Because it's one thing for me to run through a level and know where all the pickups are and know where all the secrets are and know where all the enemies are. And it's a completely different thing for somebody who doesn't know anything about the game to go in and suddenly have to experience a very difficult AI. So balancing is going to be interesting there. But for now, I adjusted the vision and hearing distance, which is a pretty big step considering how busted it was before. And speaking of enemies, I got them placed in the map. And as you might think, we got more of E1M2 built. We got the secrets put in. We got the enemies put in. We got the pickups put in. We got the ambient sounds put in. We got the nav mesh put in. Sounds to me like E1M2's pretty much done. So we actually did manage to finish it on time despite a couple of setbacks. So that's nice. Now, like I mentioned, we're not going to go into E1M3 just yet. I'm going to have to kind of take a week to touch up enemy balance and fine-tune player movement, which is another thing that I did. I tried to make the player movement just feel a little bit smoother. Like I was feeling the acceleration a little too much, so I want to make it to where it's really snappy movement. And right now it's much better than it was, but that's another thing I'm gonna have to fine tune, and that just means playing the game as I have it. Because I actually found that the player movement, it was okay for moving around, but when it came to having to kind of jiggle peek corners, didn't actually work out too well. So now it's much better. So this week we're gonna be doing a lot of balancing work. Now, that's it for the updates, really, but I did promise I would talk about the elevators some. And the elevators, like I said, are a very good example of what it is to make something in a game. And I'm sure if anyone here has done coding before, then you'll know that simple things aren't exactly simple to make. All right, welcome to the Unreal Editor. As you can see, we have got a spot to spawn, a spot to stand, and an elevator. Make it a little bit easier for you to see. So an elevator at its core is a very simple concept. It's just a box that you can stand in that moves up and down. So let's start with the first problem, moving up and down. How do you get it? Where do you move it to, essentially? Well, you could say, I just want it to move 10 feet up. Okay, that's fair enough, but comes with some problems. If you are telling it to move 10 feet up, then what is to stop it from being able to move up multiple times? So you would have to figure out a way to set it to realize that it is at the top floor and not be able to travel further, because every time you press the button, there's nothing telling it this is where they want it to stop. You would just constantly add 10 feet. So it would just go up and up and up and up and up. Another problem is that if you have it set to a flat amount, like just 10 feet, there's no versatility to it. So you would have to build your levels around your elevator travel height, which is not very good from a workflow standpoint. So you kind of want another way rather than just taking the current height of the elevator and adding or subtracting a flat amount. And one of the things, really the way that I found out that works very well for me is I made some collision boxes that are the same size as the elevator. And these collision boxes can be referenced in the code. So you are able to take the location of the up location box and the down location box, and you are able to just say, okay, elevator, move from where you are to the location of this box. And that works. But that has another problem. If you tell it to just go, if you say make the elevator's location the box's location. Then you are going to teleport this elevator up to that box. So you need to have a travel time. Well, really, if you wanted to just kind of be clever, then you could just teleport the elevator to the point. As long as the player can't see that they're being teleported, then you could just fake that it's moving with some sound effects and things. But that's not the route we went. So we'll just say we wanted to travel. We wanted to physically move from point A to point B. So now we're going to look into the code to actually see how that goes. Okay, now welcome to the elevator code, which there's quite a bit of here, but also some of you who know Unreal might realize, oh, he's coding this all in blueprints, which, yes, I am. I don't know how to do whatever. I think it's, I don't know, remember if Unreal uses C++ or C#, but I don't know how to code in those. So, yeah, blueprints are a very, very nice and accessible way of being able to code. So, good on Unreal for the blueprint system and expanding it so much. So, here we go with our travel time. What we want to pay attention to is this node right here. This is a timeline, or essentially a timer. We're setting a timer from 0 to 1. So 1 second. Here we've got the set world location. This is what would essentially teleport our elevator. We're saying, elevator, go to this spot. And this is the X, Y, and Z coordinates. For people who do not know, X, Y, and Z is the coordinates of a 3-dimensional area. So we've got left and right, forward and back, and up and down. Z is the up and down axis. So that's the one that we want to pay attention to for our elevator. We don't really want to change our X and Y values because you don't want your elevator to move in those dimensions. You only want it to move up and down. So you can't see it right now, but these are the same X and Y coordinates that it already has. So we're not changing these. We're only changing this. So you might notice that this lerp vector node is connecting these two together. And that is an interpolation, a vector interpolation, essentially. So to explain this, this is the starting Z location and the ending Z location. And then alpha is our interpolation value. So now, what does all that mean, really? This right here is the timeline, or the timer itself. So we are setting the timer that moves from 0 to 1 seconds into the interpolation spot here, which is saying basically to update the location between A and B over the course of this time. And then we have this connecting the update section to the world location, which means that as this updates, so as the timer goes on, it is changing the Z location. So essentially that's meaning that it will gradually move up until it hits this point. So that's great. Problem solved. We know how to make it actually physically move. But there's another problem. That would mean that our elevator would only move across 1 second. Which, that's fine if you only are going to move it the same distance, but what if you're going to move it further sometimes and shorter distances some other times? Naturally, it would take longer or shorter to travel from point A to point B. So then you would have to find the difference in distance and try to set a constant travel rate. So we can go all the way back here, the big thing that we would need to do is be able to change the overall duration of our timer to be either shorter or longer. Fortunately, you are able to do that. Since we are able to change the duration of the timer to a variable, that means that before we even run the timer, we can actually do some math and figure out a constant travel rate. And that is done right here. You can see we have the elevator room location and the goal location. So point A, point B. We're taking the value of the Z location. So we're taking the coordinate value of A and B and subtracting them to find the difference between them. And then it's easier to explain these two together. So this is saying we want across 1 second to travel 1,000 units. Now you could set that however you want. If you wanted to move faster, then you could set it to like 2,000 units. If you wanted to move slower, you could set it to move like 50 units across 1 second. But this is what I've decided. So 1,000 units per second. So we're finding the overall distance between these 2 points and applying that travel rate, getting the absolute value, which if you don't remember, absolute value is just making that number positive because it's going into a timer. So you don't want to have a negative number going into a timer. And using that, we're able to set a constant travel rate. Okay, so now we have the physics of how to move our elevator, but how do we initiate that movement? And it is just like in real life. We use a button. However, that has its own problems because, of course, it does. You can't have anything new without a problem coming up for it. So, right here, let's just pay attention to this. This is our button code. This section right here uses a gate. Gates are very important for interactable items. Essentially, this is saying gate, so this is what triggers the gate. So pressing E on your keyboard, for instance, pressing the use button will check the gate. If it is open, then do the code. If it is closed, do not do the code. How do you get it to open? That just means that the player needs to be overlapping with this collision box. This is an invisible box in the game that will say, okay, they're close enough to be able to use the button. And then this is our close condition, which is saying when the player is no longer overlapping the collision box of the button, then don't run this code. The reason why this is important is because if you did not have this and you just had this connect directly to the code, then that would mean that you could interact with the button from literally anywhere. So every time you press the interact button, it would press the button in the elevator. All right, so we can physically interact with our button now, but of course, that causes other problems. What happens if the player presses the button when you don't want them to? And what happens if they try to spam the button? Now, what could possibly happen? One thing that's kind of obvious is the button could click multiple times. Some people might want that just for the interactability, but I personally prefer to have the button not make a sound effect if nothing is going to happen. That way you're using the click as kind of an audio trigger that, okay, something's happening. If they try to press the button and it doesn't make a sound effect, then they know that, okay, nothing's going to happen. I can't press the up button anymore. So we have a do once node here and plug in a custom event into it, which is essentially saying you will do this code only once, but it can be reset once the reset start button event is triggered. So we essentially put that at the end of all of our code right here. Now, what other code could we not want the button to execute? Well, let's say you're at the top floor, and when you press the up button, that triggers the door on the elevator to shut. Well, if you're on the top floor, it kind of defeats the purpose to shut the door if you're not going to move anywhere. So you need to be able to tell the button, okay, we're at the top floor, this button doesn't do anything, or this elevator doesn't move up. Like, this elevator was never supposed to move up, which is a setting that we are able to set right here. As you see, go up and go down. That way I can set the elevator to be an up only elevator, a down only elevator, or an up and down elevator. So we can just save that, and now we can make the elevator go up and down. So now we know that the elevator can move up and down, but how do we get it to detect that it is on the top floor? Well, you are essentially going to check. Basically what I did is there's a lot of code here. You can see there's the start boolean, and booleans are basically it's either on or it's off. So elevators begin with the start boolean on. That is essentially saying this is at the middle floor, or the top floor if it's a down only elevator. It is at the original middle location. That way, when you press the button, you can keep track. You can check: is it at the middle location? Is the elevator able to physically go up? Then you need to check the location of it. This is essentially saying, is the elevator room's location, is it the same as the up location? And if it is not, cool, then it can go up. If it is, then you're resetting. This is essentially resetting the up button. So this is another issue where you still need to be able to reset the button, because, so let's say if you run this code, so you try to tell the elevator to go up when it is at the top floor. So you go, okay, well, go back down. So you send it back down, but then you want to go back up later. If you didn't have this reset, then the do once node would already be triggered. So you would never be able to press the up button ever again. So even when it fails, you need to reset the button. So do not forget that. Now, that runs into another issue, which you might have noticed I passed over the nearly equal float. You'll run into an issue where, as you move the elevator up and down multiple times, because it's never going to move at a purely constant rate. There's always going to be some delays. And what that's going to do is over time, that's going to shift it to where it is no longer able to be in the exact same spot. So basically what will happen here is it will essentially never recognize that it is at this point. So it will never be able to be equal to the up location. So you need to set some kind of tolerance to it. So that way you can basically just use like however much tolerance you want. I set 5, so it doesn't get very out of spec there, but you still need to set some kind of tolerance. Otherwise, the elevator will get stuck because it won't recognize what floor it's on. Which leads me to another issue that can happen when you are trying to detect these spots. So you might notice this is up point, but in the code here, what I was showing you the box is physically called up location. Now, one problem that you might run into is the elevator might not detect the location that you think it is. By that I mean, you might say, like, make the location of the elevator the up location, so the location of this box. But where is the location of this box? If you think, well, maybe it should just be the actual box itself. Like, it tries to overlap the box. Congratulations. That's what I thought. Right up until it stopped halfway through the box and got stuck in the elevator shaft. So it had to make a more specific spot for the elevator to get to, which is this little ball here that I named Up Point, which is at the very, very, very top of this box. So that way it kind of guarantees that it is going to travel to that spot until it hits there, and it's just a more precise location. So I had to make the locations more precise too. So now we know how to tell the elevator what floor it's on, and we know how to get it to travel at a constant rate. We know how to get it to stop to where it knows about where it is, and it's not going to stop in the middle of the shaft. You might think that's all the problems that are done with. Not quite. So let's say that the elevator is on a different floor, or the player is really, really determined to be stupid. For that, let's go into the editor here. Got the elevator open. Let's press a button and then jump out. Uh-oh. How do we get the elevator to come back? You need a call button. Yes, these are things that I specifically test for, because these are stupid things that I would do just to see if I could break the game doing it. So the call buttons are pretty much the same as the elevator buttons, except they are tied to a specific spot. So that means that the bottom button will always call the elevator to the bottom location, middle button to the middle location, top button to the top location. And that's pretty simple. We already have it set up to where, if it's already at the middle location, then it won't do anything. But now, what if our elevator does not go up? What do we do with the up button then? Because we would still have it. It would just be floating there doing nothing. So we need to get rid of it. And here we go with the direction enable check. So we are checking, can the elevator go up? If not, this is just a little bit of redundancy to set the up location to the start location. This is to make sure that it knows absolutely, without a doubt, that the up location does not exist. So it cannot travel up. And here's what we're talking about, the call button. Call button visibility. If you cannot go up with the elevator, make the up button, or the call button for the top, make that invisible. If you can go up, then make it visible. And then we have this right here, cover door top, destroy component. What is cover door top? Well, that takes us to another issue. What if you are on a floor where the elevator is not? You can call it there, but there's a problem. How do you stop the player from just walking into the open elevator shaft? I don't think I need to explain why that's a problem. You need to find some way to stop them from walking in. And so you have shaft covers, which you can't see right here because I have them hidden in the editor, because I don't need to see them in the editor. But if we play the game, you can see the shaft cover right there. You can see the shaft cover right there. And you can see the shaft cover right there. So we have the shaft covers put in. But then we run into the issue of, what if this elevator can't go up? We would just have a random shaft cover. Well, we could make it invisible, but the shaft cover is specifically meant to block the player. If it's invisible, you just can't see it, but it is still physically there and is blocking the player. So if you do not have the up location, and we make the up location the start location, That means the player can no longer enter the elevator because an invisible shaft cover is blocking the way. So we need to just destroy it. So we basically delete it. Now, that runs into another problem. So we have the cover options here. So we see bottom cover open. So open the bottom shaft cover. Now, right here, this should look pretty familiar. This is just moving the shaft cover from left to right. This would be, if you're opening it, then you move it to the right, and you move it across a timeline. But what happens if you do not have it? So you deleted it, but you have code that says to do this. You have code that says to open it, but you deleted it. The game will throw an error because it is trying to interact with something that is no longer there. So you do an is valid check and just check, does it exist? Yes, do this. If it doesn't exist, don't worry about it. So that'll prevent the errors from getting thrown. And then we need to manage the door covers here, which sets up every scenario to open the shaft cover on the floor that you are on and shut it on the floors that you're not. So is the elevator at the top spot, open the top shaft and close the bottom and middle. Is it at the middle, open the middle, close the other two, bottom, same thing. So that is where we are at now. Hopefully this was able to kind of give you an example of something very simple that turns out to be very complex and how a solution can cause multiple problems that need to be solved. And finally, let's just end this with our functional elevator. Up button does nothing when we're at the top floor. Press down, goes down. We go up, opens, drop down. Shaft cover is shut. Press the button, and the elevator comes down. Working perfectly as it should. You'll love to see it. So that's it for this update. Thanks a lot for watching, everybody. I hope you enjoyed it. I had some people say that they wanted to see a little bit more into the development side of things rather than just getting some updates. So hopefully that little look in the editor gave you a little bit more of an idea of what I'm doing, and I'll try to give you more looks into it. I don't necessarily want to make it, I don't want to spoil too much of the game by showing you too much of the game itself, but I also don't want to bore people with some of these updates, because I know some things, when they start getting a little technical, they can get a little boring. So I'm going to keep trying to feel this out, but I really appreciate you guys watching, and I will see you guys next week.